Okay, now we're going to get into what is referred to as proving. Now, like in this case, it wants you to prove that the left side is equal to the right side, which means all of your work will have to be done on the left-hand side of all of these problems. Now, like in this case, there's not anything you can do on the right side because you have just a positive 1, but in a minute you'll see where there's things on both sides, but you're simply to work with the left side, simplify it, use your identities, do some simplifying, and prove that that left side will simplify to end up being positive 1. So this is not like solving an equation. You're not going to be moving things from the left side to the right side. Like I said, you're just going to simply totally ignore the right hand side, do what you can to this left hand side, but when you're finished it should come out to be equal to positive 1. So some of the stuff that you've already seen me do and talk about is what we'll actually apply here. Now, it doesn't say to change to sines and cosines, but that's just kind of like an unwritten rule when you're trying to prove something. Typically, if you'll go to sines and cosines, that'll make it a good bit easier. Alright, so starting out, if I'm thinking about going to sines and cosines, I wouldn't do anything with my first term. Okay, of course, these being side by side is multiplication. I had something like that just a few minutes ago. I'm going to replace cosecant with 1 over sine. And if I'm going to sines and cosines, then for tangent I would need to use my ratio identity, which is sine over cosine. Okay, now this cosine that I had here as the first factor, remember, is understood to be over 1. Now since you're multiplying, then there's cross-reducing that you can do here. So you have a cosine in the numerator, cosine in the denominator, so those will cancel out, and your sines will cancel out, so that leaves you with a 1 on the top, a 1 on the bottom, and 1 over 1 reduces to 1. So that's why I say whatever you have on this right hand side, this side should always simplify down to be exactly the same. Make sure you are showing me all of your steps, okay? You know what your answer has to be. Your answer is always going to be what you have on this side. You got to have all the steps to prove that to me. So do not do anything in your head. I mean, if you leave out steps, then I'm just going to have to assume that you didn't know what to write down, okay? So make sure you show them all. Alright, second one. Okay, so in this case, again, I'm going to leave the right hand side alone, and I'm going to work with simply just this side. So I had a fraction like this a while ago that I did some simplifying with. Again, keep in mind, go to sines and cosines. So I'm going to replace secant with 1 over cosine. And then I'm going to replace tangent with sine over cosine. Now, even though I'm changing this side to be sines and cosines, I do nothing to the right-hand side. That has to stay cosecant. Alright, so let's use that simplifying that I had used earlier. So I would do the very top times the very bottom. So 1 times cosine is cosine. And then when I multiply what I have in the middle, that would give me cosine times sine. Okay, so next step of simplifying here would be to cancel out your cosines. So you're left with just an understood 1 on the top. So I have 1 over cosine. And then 1 over, oh, I'm sorry. This right here was supposed to be a sine. So make sure you fix this. Cosine times sine, which means this is a sine. And then you have the reciprocal identity that says 1 divided by sine is cosecant. Okay, so when you're working out, again, this left-hand side, make sure you carry it all the way down until this last step, you're actually getting what you have on this other side, okay? Now, if you want to, and I'll do this on the next problem, you really don't have to keep writing down this right-hand side. A lot of times what I'll do is just kind of like draw an arrow down through there and then just write it on the final step. I'll show you what I'm talking about when I do this next one. That'll just save us a little bit of writing. Okay, number 3. Okay, so again, keep in mind, go to sines and cosines. So in my numerator, using my reciprocal identity, I'm going to change cosecant to be 1 over sine. Now that's being multiplied times tangent, so I want to change tangent to be sine over cosine. And my denominator being secant, I want to change that to be 1 over cosine. Okay, so doing the multiplication in my numerator, my sines are going to cancel each other out. So I have 1 over cosine left on the top, and I've got 1 over cosine on the bottom. Now, you actually could go straight to your answer right here, because you could look at it this way. Your numerator is exactly the same as your denominator, so I mean, that's just the same thing as like if I had 5 over 5. Anytime that your numerator and your denominator are the same, it always reduces to be just 1, okay? So you could go from here to say that you've got your 1 and you're done with the problem. Now, if you don't catch that, you can do another simplifying step. You'd multiply the ones on the outside together and multiply the ones on the inside. So you do 1 times cosine, which is cosine. And then in the middle, cosine times 1 is cosine. And now you might catch the fact, hey, my numerator and denominator are the same, therefore that's just a 1. So what I was meaning about drawing the arrow, like I kept my equal sign going down through there, I just didn't bother writing down those 1s each time. So like you could just come up here and just draw an arrow down here to the bottom and say, okay, well I've got 1s all the way down through there. Of course, writing 1's not hard, but you wouldn't have to write it if it was something more complicated. Okay, let's look at one more. Okay, going sines and cosines. So I'm going to leave this first term as it is. Ratio identity, so I can change this to be cosine over sine. And you would want to leave this as sine. Alright, so we have multiplication, we have addition. We've got to multiply before we can add. Now when I go to multiply these two fractions together, of course this is understood to be over 1. So cosine times cosine is cosine squared. And then 1 times sine is sine. Okay, so now you're ready to do the addition. That's understood to be over 1. So you are going to have to get a common denominator. Okay, so this is just like what I took you through earlier. Your common denominator will need to be sine. Now your first fraction, you just bring the numerator down as it is because it already has the denominator that it's supposed to have. Now your second fraction, of course what you're missing there is the sine, so therefore you got to multiply the top times sine. So you have a sine times a sine, which is going to give me a sine squared. Okay, now I can add those together since I have the same denominator. Now these are not like terms, so I can't physically combine them. Okay, now keep in mind what we're working toward here. Okay, I've got cosecant. Now I've got everything in terms of sines and cosines, so you should hope that you probably end up with just some sines, because you can take a 1 over sine to be your cosecant. Alright, look back at your Pythagorean identity, and we used this a while ago. Now, in the problem, again, I have cosine squared plus sine squared, but that's okay for those to be in reverse order since it's addition. And this is equivalent to just 1, so that means that I can replace my numerator with a 1. And then I know my reciprocal identity, that 1 over sine is equivalent to cosecant, which is exactly what we were trying to come up with. That was my right hand side.